Okay, welcome everybody to our ACOM seminar today. The usual seminar organizers aren't here, so I have the pleasure to introduce Alan Robock today, who is currently visiting Boulder for a few months. So Alan is a distinguished professor of climate science at Rutgers. He graduated from the University of Wisconsin-Madison in 1970 and got his PhD in 1977 in Massachusetts Institute of Technology in Meteorology. And now he was a professor in the University of Maryland from 1970 to 1977 to 1997, so 20 years. And now he is a professor at Rutgers. He is well known to NCA and to UCA. He was one of the UCA, a member of the UCA Board of Trustees, and he collaborates with several researchers here with us, for instance, on geoengineering, on nuclear war, and on other things. And today, Alan is talking about climate and humanitarian impacts of nuclear war. Thank you.
Okay, thank you very much for inviting me. It's nice to be here at NCAR. I'm going to start with an advertisement. I'm an associate editor of Reviews of Geophysics. It's the most highly cited journal in our field. We just got a new impact factor, 16.7. So I invite any of you that has a review in you to contact me or the journal and submit a proposal. Within 2 weeks, we'll give you a response. There's no page charges. It can be as long as you want, and everybody will read it. Now, this is an atmospheric chemistry lab, so you all know who Sherry Rowland was. He, along with Mario Molina and Paul Crutzen, won the Nobel Prize in Chemistry. And this is his obituary in EOS from 2012. And in here he says, is it enough for a scientist simply to publish a paper? Isn't it a responsibility of scientists, if you believe that you've found something that can affect the environment, isn't it your responsibility to actually do something about it, enough so that action takes place? If not us, who? If not now, when? So this philosophy is what inspires me to work on this topic. People say, why do you work on something that's so depressing? And this is why. We've discovered a danger, and I want something to be done about it. So the talk's going to be organized in 4 areas. The theory of nuclear winter. We can't test it in the real world, so we use analogs to test it. I'll briefly discuss that. And then I'll talk about policy implications, and then I'll talk about what I'm doing to do something about it. So I'm talking about work done by many people, not just me. And so this is some of the people working with me now on it and have worked with me in the past, Mike Mills and Chuck Bardeen, who are here, and Brian Toon at CU, and Rich Turco and Gera Stenchikov. These 3 wrote some of the original papers on nuclear winter, and Lily Shah, and Josh Koop, who's my student now, Luke Oman, who worked with me before, and Jonas, who's working on agricultural impacts. Who's paying for this? Well, we have a big grant now from the Open Philanthropy Project, which is funded by Facebook billionaire, but before the Defense Nuclear Agency at one time funded it, and people at NCAR and at Rutgers do it on their own, and I've used an NSF grant and on volcanoes, and the Swiss Federal Department of Foreign Affairs gave us a small grant. We've written many journal articles about this, and there are several others that are in review right now, and several others to come. And so you can download all these from my homepage if you want to read more about the details. I can't talk about all of it, but we've written in Science and Nature, but we've also written in Scientific American to try and make the public aware of it. Here's the story. Here's our beautiful planet, and after a nuclear war, it might look like this, with clouds of black soot covering the planet, being heated by the atmosphere, and then being transported around the world. And if there's enough soot, temperatures will get below freezing at the surface, and you can have, it'll be cold, dry, and dark, more ultraviolet because of ozone depletion, and it would affect the agriculture. Crops would die, and there'd be global famine. The amount of climate change depends on how much soot is put in the atmosphere and what its properties are. Here's a history of the number of nuclear weapons deployed on the planet. And it started off at 0, and I've plotted the 2 of the countries that have the most ones, Russia and the US, and the total, which includes all the other countries. Can somebody tell me how many countries have nuclear weapons? 5, 17, 10? Okay, the correct answer, and this just proves that consensus is the best predictor. The correct answer is 9. And so...
Did you count Israel?
Yes, although they won't admit it.
No, that's right, I'm asking.
Yeah, I counted it. So why did the arms race end? Crutzen and Birx published their paper on the climatic effect, the effects of nuclear war on the atmosphere, and said there would be smoke, and smoke might cause climate change. And then climatologists started to work on it, and a team from Russia, Alexandrov and Stenchikov, a team from the US, Turco, Toon, Ackerman, Pollack, and Sagan, both calculated the climate response, and they both found the temperatures would get below freezing. It would be nuclear winter. And then the next year, a group at NCAR, Kirk Covey and Steve Schneider and Starley Thompson, and then I also published a paper looking at the long-term effects. And then the arms race ended. So I assert that science actually informed policy. I'd also like to point out there's other theories, of course. The Soviet Union ended 5 years later, so it wasn't the end of the Soviet Union that did it. There were lots of protests, of course, at the time. I'd also like to point out that the number today is not 0. There's still almost 10,000 nuclear weapons deployed. We do research by looking at data, running models. Historians do it quite differently. They just ask the people that were involved. So this is my evidence. Ronald Reagan said, a great many reputable scientists, he called us reputable, are telling us that such a war could end in no victory for anyone because we would wipe out the Earth as we know it. If you think back to natural calamities back in the last century, in the 1800s, volcanoes, we saw the weather so changed. There was snow in July in many temperate countries, and they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange and nuclear winter? And Mikhail Gorbachev, the other person who decided to end the arms race, was the leader of the Soviet Union. Models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. That was a great stimulus to us. That was a long time ago, more than 35 years ago. Why are we even talking about it now? So I want to ask 2 questions. Could the current nuclear arsenal still produce nuclear winter with temperatures below freezing? And now we know there's 7 more countries that have nuclear weapons. What if one of those, or a couple of those countries with a very small arsenal had a nuclear war? What would the consequences of that be? And so if you got more work to do, I'll answer these questions right now. Yes, we could still produce a nuclear winter, and it would last for many years, much longer than we thought before. And if there was a war, say, between India and Pakistan using less than 1% of the current arsenal, it wouldn't make temperatures go below freezing, but it would be a large climate change with the direct effects would be horrible, but there would also be indirect effects on global agriculture for more than a decade. We can do this now because we have bigger and better computers and better models. So you've all seen the Cray 1A. This is a museum piece now. It's sitting in the basement up at the Mesa Lab. This is the one that the team at NCAR used, and they could do 20-day simulations with an atmosphere-only model, no ocean, no stratosphere, and your iPhone is orders of magnitude more powerful than that. So now we can actually do decade-long simulations with the tools that we have now. And the initial experiments also pushed models to include aerosols because the climate models at the time couldn't deal with aerosols. So what does a nuclear bomb do? This is one of the tests in the desert of Nevada when they were still testing outdoors. You can see the dignitaries here sitting with their fingers in their ears and sunglasses on, and the light comes from the light of the bomb. So it's like bringing a piece of the sun to the Earth for a fraction of a second. About a third of the energy goes out in light and radiation. And they built a house to see what would happen. So you can see it's lit, and as the fireball rises, you can see the shadow gets shorter, and then it starts to burn. But then the blast wave hits like thunder following lightning, and say, well, it's going to blow out the flames, but it's also going to break the gas mains, it's going to break the electrical wires, and you can imagine the fire reigniting. Cool? I don't know. That would not be my... it also depends. So if you drop the bomb on the desert or on the ocean where the outdoor tests were, nothing's going to burn, and you won't have any smoke, and there won't be any climate effect. But if you drop it on cities, industrial areas, then there's a lot to burn. And if you drop it on an oil facility, then you get this black city smoke. And it's the black city smoke that absorbs sun better and produces large climate change. And so we're working now to try and figure out what's actually in there. Is it pure carbon? Is it organics? Is it carbon coated with organics? And that makes a difference. During the first nuclear war, a 15 kiloton bomb was dropped on Hiroshima. And so that's equivalent of 15,000 tons of explosive power from TNT. And that's 1% of a megaton, which is the units now we use for size of nuclear weapons. This was so powerful, our current arsenal is so powerful that if you dropped one of these bombs every 2 hours, starting on August 6, 1945, 12 times a day for more than 70 years, you still couldn't use up our current arsenal. It was dropped by the B-29 called Superfortress, called the Enola Gay. It was named after, there's a picture of me when I had hair and it was black, at the Smithsonian when the plane was stored in a warehouse, and this is a mock-up of the bomb, the uranium bomb that they dropped. And on the side of it you can see Paul Tibbets was the pilot, and Enola Gay was his mother's name, so he named it after his mother. The plane now is at the Air and Space Museum Annex out by Dulles Airport in Virginia. So if you ever have time between planes there, take an Uber over there. The museum's free. It's a spectacular museum. Here's a drawing of what it looks like when the bomb dropped. And this is what one of the survivors remembers. It was the fires and the smoke. If you look at Hiroshima afterwards, all the buildings burned, and they cleaned up the streets so you could walk around. 3 days later, we dropped another bomb on Nagasaki. It was called Fat Man. It was a plutonium bomb. So this is from the museum. There's a picture of Fat Man and the bomb. And this is what Nagasaki looked like afterwards. Unfortunately, we have a couple other examples of cities burning. In 1906, there was an earthquake in San Francisco, and it tipped over things, and the city started to burn. Jack London, the famous author, was asked to write an article for Collier's Weekly, which was a popular magazine. He did it from out on San Francisco Bay. Within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower visible 100 miles away. So that gives something about the time scale of how long it takes the fires to burn. And for 3 days and night, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration found in the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. So that's a classic description of a firestorm. That's what San Francisco looked like afterwards. This is taken from kites. There were some stone buildings that survived, but everything else burned. So, as I mentioned, the Swedish journal Ambio had a special issue on nuclear war, the aftermath, and Crutzen and Birks were looking at tropospheric ozone, which needs sunlight, and they said there'd be all kinds of chemicals in the atmosphere, but we need sunlight to make ozone, and boy, that smoke could affect climate. So the first paper was by Turco, Toon, Ackerman, Pollack, and Sagan, and I'm still working with Brian Toon on it here, and Rich Turco's retired, but he's still working with us a little bit. So this paper was published in Science. It was a single column model. So the whole atmosphere was in one column. We call it a radiative convective model now, or single column model, with no heat capacity at the surface. It was land, and they ran it for 300 days with different scenarios of how much smoke they would put in. Their baseline was 5,000 megatons of nuclear weapons, and they put them on different targets and calculate how much smoke and dust would come. And this is time from 0 to 300 days. Temperatures rapidly would plunge below freezing. And then they didn't know how long the smoke would last, so they had it only a few months based on what we knew about aerosols in the troposphere. And then the temperature warms up again. At the same time, in Russia, Alexandrov and Stenchikov did the first GCM simulation. And their paper was distributed a week before the TAPS paper, but they worked with them and they learned about it from the TAPS group. And it was a very, what we would call, even back then, low resolution, 12 by 15 degrees, horizontal resolution, 2 levels, the Mintz-Arakawa GCM. I met Alexandrov here at NCAR in 1978 when I spent a couple weeks here at the invitation of Steve Schneider. He and Vladimir Sergin came here for 6 months. He showed up with 2 boxes of cards, computer cards, of the Mintz-Arakawa model he was going to run, so he brought the program with him and 2 boxes of cards. So this is figures from their paper. This is the zonal mean circulation at the beginning. There's a upward motion, the ITCZ here, but after 297 days, all the smoke in the northern hemisphere would be heated and lofted and pushed toward the southern hemisphere. So these simple mechanisms of cooling the surface and changing circulation, even with a low resolution model, you still got it. And this is on day 40, the change in surface temperature. So they didn't have an ocean, but where the blobs of smoke came, temperatures might be 20, 30 degrees cold.
The Russian calculation.
This is the Russian calculation, yeah. And then I did a paper with an energy balance model, so it didn't have dynamics, but it had latitude and seasonal cycle and the snow albedo feedback, and it was published in Nature. Back then, you could publish radioconvective models and energy balance models in Science and Nature. And this is my graphics. We had this pen plotter where it would grab a pen, go like this, and then grab, and with NCAR graphics, and so the temperatures over land with a springtime injection would go 12 degrees below normal, but the smoke was gone by here, but it's still the signal persisted, and that's because of the snow albedo feedback. You got more snow, and in the spring it would enhance the cooling. And then here at NCAR, Starley Thompson did some simulations, and with the NCAR GCM, 20-day simulations for winter, spring, and summer. And the way they did the graphics is they had a computer screen, and they took a 35 millimeter picture of it and made slides, and that's how they got these pictures. This is the place where they would put the smoke in. You can see the resolution. Steve would say this is what the world would look like if the Army Corps of Engineers got a hold of it. And on day 5, so they put it in between up to 7 kilometers, and in the northern hemisphere between 30 and 70 degrees north. And so it was already being heated and lofted, and then by 20 days it got into the southern hemisphere. A lot of it fell out already. You'll notice there's no stratosphere here. There was no ocean. This is the absorption optical depth at day 20, and so in case you've forgotten what these numbers are, the darkest gray is less than 10% of the light would go through. So it would cover most of the land in 20 days. And this is the temperature change, and so the green areas are between 15 and 25 degrees Celsius below normal. So this is the world's nuclear arsenal today, 13,880 weapons. The symbols up here are the types of weapons. The green is land-based, the blue is submarine-based, the red is on aircraft, and the gray is ones waiting to be dismantled but still exist. And this is the US, this is Russia, and these are all the other 7 countries, which is kind of hard to see, so I'm going to blow it up for you. And the US and Russia each have 6,000 something. France, China, UK have a couple hundred, Israel 80, Pakistan, India 100. The number is going up. These are the only 2 countries that are increasing their arsenals, and maybe North Korea is, and we're not sure. So this brings up, so you notice France doesn't have any land-based missiles, neither does the UK. So there's no targets like there are up the road here for enemy missiles on land. It also brings up the question, why do they have a couple hundred? If you consider nuclear weapons a deterrent, how many do you have to put on the capital city of your enemy to deter them from attacking you? So 1. So maybe you need 2 in case the first one doesn't work. So a couple hundred is more than enough. They could build as many as they want. So that brings up the question, of course, why do the US and Russia have thousands?
Because you have to survive a first strike and still be able to devastate people.
Yeah, but if you have, so that's true for these other countries too. If they're all on, oh, by the way, I guess people are listening. Eric said because you have to survive a first strike. If they're all on submarines, which are, nobody knows where they are, then you don't have to worry about that. All right, can somebody tell me where this is? This is a photo taken from the International Space Station. What?
The islands of the Great Lakes there.
The Great Lakes, no? This is an international border. It's the only lit up international border in the world. Pakistan and India, that's right. So India, Pakistan, Afghanistan. And all these lights are cities, huge cities. So Karachi, 24 million people. Faisalabad, you never heard of it, 4 million people. So these might be targets if there was a war between India and Pakistan. There's a lot of stuff to burn there. So it was maybe 12 years ago now, I was at an AGU meeting and ran to Brian Toon and Rich Turco, and they said, you know, we calculate how much smoke there would be from a war between India and Pakistan. And I said, oh, that sounds like a lot. Who's going to calculate the climate response? I said, well, we thought maybe you would. So that's got us going on this again. We didn't have any resources. We just did it in our spare time. Luke Oman, my student, was modeling volcanoes with the GISS Model E 4x5 degrees. And so he just put in soot, which is one of the aerosol types in Dorothy Koch's scheme. We just put it in the stratosphere, see what happened, and it did a very good job without having to do anything special. So we asked, what if India and Pakistan had a nuclear war? So in Kashmir, you can imagine that a skirmish could get out of hand because of poor communication, misunderstanding, panic, and fear. And it's happening all the time. So this is from the New York Times, 2016. Fighting intensifies, and 19 people were killed on the border. In 2017, 7 were killed on the border. In February this year, a vehicle filled with explosives on a busy highway killed 40 soldiers. And then, if you remember, a Indian airplane invaded Pakistan, was shot down, and so then militants killing an army major and 3 other soldiers. So that's the place in the world we think might be the most likely to start a nuclear war. What about this? Some Americans were really happy about, we killed Osama bin Laden. But imagine you're Pakistani air defense and you see this invasion coming, even though they're stealth. Who would you think would be invading you? Did this risk possibility of a Pakistan-India nuclear war? Fortunately, it didn't happen, but I wonder if the planners thought about that. So we calculated how much smoke you would get from dropping a 15 kiloton atomic bomb, the same size as was used on Hiroshima, on the 50 targets in each country with the most amount of stuff to burn. And for India, it was about 3.5 million tons of sooty smoke, Pakistan 3 million. So the total was 6.5 million tons of smokes, or 6.5 teragrams of smoke. So I decided to be conservative, just use 5 teragrams, and so this would only be 0.03% of the current world arsenal in terms of explosive power, 100 Hiroshima-sized weapons. And the direct effects would be horrible, but it would produce 5 million tons of smoke. So we calculated how much the climate would change. This was done 12 years ago. And so here's a movie. This is the horizontal distribution, and this is the tropopause. So very soon, the soot would be heated by the sun, lofted into the stratosphere, and blown around the world. And it would last for years. We didn't know that before, but now we have the tools to do that. This was a fairly low-resolution model in terms of levels, but it went up to 80 kilometers. So now we assumed that the soot particles were 1/10 of a micron radius and did not grow and were not coated by organics. So they would be very effective at being heated, and they would fall very slowly, and that's one reason why they would last for so long. And then Mike Mills, and so if you plot the global average temperature change on the global warming we all know and love, it would be instantaneous climate change to temperatures unprecedented in recorded human history. Temperatures below the Little Ice Age. It wouldn't be nuclear winter, temperatures wouldn't get below freezing, but it would be a huge climate change. Now, so everybody says, well, models aren't perfect. Can we believe this model? So 2 other modeling groups did the same experiment with the SOCAL model in Switzerland and with the Wacom here at NCAR, and they found basically the same results. So Mike had much better graphics, and so he drew this diagram, and this is the soot, and you can see it rapidly goes up to the stratopause. And this is in April and May, so it's the northern hemisphere. The sun's over here, so the soot is lofted in this direction, and then as the year goes along and the sun goes to the southern hemisphere, the soot stays up here. And this is a logarithmic scale, so there's very little leaking into the troposphere. And the e-folding lifetime was about 7 years for the soot.
What would happen to ozone?
I'm getting to the question, what about ozone? I'm getting to that. Ozone would be destroyed by all the heating. You would also have large temperature changes in the ocean, because this had a full ocean. And with our new team working on new simulations that Chuck and others are doing, we are looking at the ocean biogeochemistry, and you get a nuclear El Nino that lasts forever for 10 years, and we have huge impacts on the biosphere. But even then, several years ago, we knew that there would be huge changes of temperature in the ocean, and now finally we have a team that's looking at the impacts on, if you can't grow food on land, can you eat fish? And so we're looking at that. So Guy asked about the ozone. This is from the GISS model. This is the change of temperature as a function of height, globally average, and time. So you get cooling a little more than a degree at the surface, but you have heating of more than 50 degrees in the stratosphere. And Mike did this also in Wacom and produced this, which showed normal ozone, and the 220 Dobson units is traditionally what's the edge of the ozone hole. So in the spring and October, you get ozone hole here. But with a nuclear simulation, this is 3 years after the soot injection, you basically get a nuclear winter ozone hole. And that means, and he also did this figure showing this is normally the ozone hole, and now you have these concentrations globally, and then you get a lot more ultraviolet radiation. So ultraviolet radiation is determined by the World Health Organization by this index. If it's over 8, you need extra protection being outside. And so this was Mike's simulation of June and December UV index. Red was over 12 currently, but in year 3 it was much higher, and the difference is 3 or 4 units. And so this is the difference in June, 3 years after the war. And This would have huge impacts on humans, animals, agriculture, the natural ecosystem. Even though there's still soot in the atmosphere, absorbing some of the ultraviolet, you still get more reaching the ground. And so these effects, a fair-skinned North American would receive sunburn after 6 minutes, increase in skin cancer. Land crops would be affected, and fisheries and ocean ecosystems. And nobody still has done an analysis of what these impacts would be. So that's another thing on our list of things to do. The CLM5 crop doesn't have a built-in UV response right now, but we're trying to do that offline and put that in there. We did look at the growing season. The growing season we defined as time from the last frost in the spring to the first frost in the fall. And after a year, the growing season in the mid-latitudes would go down by 10, 20, 30 days in both hemispheres. So crops would be affected by lower temperature, so slower growth for most crops, less precipitation, less sunlight, enhancement of ultraviolet radiation. So we did some model simulations of the major countries with the major crops. So corn and soybeans in the US with agibus, and rice, maize, and wheat in China, and with DSAT, and we published these papers. And the summary is that in the first 5 years, there'd be a 20 to 40% reduction of agriculture. And in the second 5 years, 10 to 20% reduction. So you can imagine how disruptive this would be to society. In 2010, there was a drought and fires in Russia, and they stopped exporting wheat. The price of wheat doubled, and that was part of the trigger for the Arab Spring. So having food insecurity can produce environmental refugees or famine. And right now we're working with new models with specific gridded crop models and looking at the impacts on different crops. I'll show you an example of that. So our new simulations are with Wacom 4, 2 degree resolution, 66 vertical layers, up to 140 kilometers. And we're using Karma, which allows the soot particles to grow. And that makes them heavier, and they fall out faster. So it shortens the lifetime a little bit. And now Chuck's doing some simulations with them coated by organics and see what effect that would have. And we really don't know what the properties of the soot would be. We don't have any cities to burn to capture the smoke and see what we get, but we're using different scenarios. So Chuck did these simulations for different amounts of soot going in. So we did the 5 teragram with a new model, 2 degree of global average cooling over land, 16 teragrams, 3 times the amount of smoke, but twice the cooling, because once you put more smoke in, there's less sunlight to hit each particle, so it's nonlinear. And to 50 teragrams, 8 degrees cooling. And so our agriculture team, led by Jonas Jagermeier, took a number of different crop models, and with 2 scenarios, the original Wacom simulation that Mike did and the new one that Chuck did with Karma, and put them into these different models. And this is, for example, for corn, in different parts of the world, how the production would go down. In Russia, 50% reduction. Global average reduction of 12% at the maximum. And this is 0 to 15 years, so it would be for a number of years to have this reduction. And then nowadays, we think maybe 5 teragrams of soot is an underestimate of what could happen between India and Pakistan, because they have more nuclear weapons than they had 12 years ago. The weapons are bigger, and the targets are a little bit bigger too. So now we think maybe 15 teragrams might be the result from a likely scenario. So if we put in 16 teragrams of soot, now we get a 34% reduction of corn. And we're doing this with other crops globally. This is presented at the fall AGU meeting in Washington, and we have a paper we're working on now. But it's much worse than that. It's much worse than that. So far, I just told you about India, Pakistan. This is a US Trident nuclear submarine. It has 100 nuclear weapons. And they're not 15 kilotons, they're 100 or 500 kilotons. So each of these has the equivalent of 1,000 Hiroshimas. So far, I told you about what would happen after 100 Hiroshimas. We got 14 of them. That's half of our arsenal. So that's 14,000 Hiroshimas, 25,000 Hiroshimas, and Russia has the same thing, so 50,000 Hiroshimas, not 100. So we decided to, there was a controversy in the 1980s, was nuclear winter real? Was the science real? Would it really get that cold? So we went and took our GISS model and redid the simulation with 150 teragrams of smoke. We did a control run, we did 50 teragrams, 150 teragrams, put in the upper troposphere over the US and Russia. How could you get this much smoke? Well, this was the amount of smoke you got in the standard nuclear winter scenario of 30 years ago, which had 1/3 of the arsenal of the US and Russia. But the current arsenal will be, if targeted the same way, or 4,000 weapons, the global arsenals of the New START Treaty could get the same amount. How come? Well, it turns out there's only a few hundred targets in each country. So if you have thousands and thousands of weapons, what do you do? So we looked at the current arsenal. You put a weapon on every target in the US and Russia, and you said, this huge pile of weapons here. Let's put 2 on in case the first one doesn't work. So this huge pile, so like 9 weapons for every potential target, even today, bouncing the rubble. So this is a simulation we did with the NASA GCM, and the optical depths are much larger, and again, it goes up into the upper atmosphere and covers the world. And the recent simulations we did with WACM, amazing. This is a global average temperature anomaly and precipitation anomaly for 15 years. The blue is the GISS run, and the red is the WACM run. So this is a much better model. It's much higher resolution horizontally and vertically, and you get basically exactly the same answer. One difference is that because the particles grow, they fall a little bit faster, and so the climate change doesn't last quite as long with WACM. The maximum is just about the same, maybe even a little bit colder, 9 degrees global average. That includes ocean. The precipitation reduction is even larger, 50%. For our GISS model, this is on year 0. So we start on May 15th. This is June, July, August. Temperatures 20, 30, 40 degrees below normal, even over the ocean, because this has an ocean, 5 degrees colder over the ocean. If you compare this to Thomson did 34 years ago, it's very similar. And in year 1, we said, well, is it really nuclear winter? So we took a place in the Ukraine where agriculture is done in the Soviet Union, Soviet Union, well, now it's Ukraine. And we looked at a time series of the temperatures. This is the daily minimum temperature from the control run for 2 years. It's below freezing in the winter. It's up to 20 degrees in the summer, below freezing in the winter. And then when we put the smoke in on May 15th, the temperatures rapidly plummet and stay below freezing for 2 years. And so clearly that's nuclear winter. Temperatures are below freezing. Even in the summer, you couldn't do any agriculture for years. With the new runs, the new WACM runs, if you look at the purple lines, the purple one is the one I just showed you, so this is just for WACM. Again, temperatures are below freezing for at least a year. So the same result. We also looked at Iowa. Now, if you look at global average temperatures from the new runs, this is, before I showed you land, this is global average. Temperatures for 5 teragrams up to 150 teragrams. And this is 10 degrees colder than normal. Remember, during the last ice age, when ice sheets were covering North America and Europe, the global average temperature was about 5 degrees. So this is ice age temperatures. And this is what we got for the GISS model. 5 teragrams, a little more than 1 degree, 50 teragrams, 150 teragrams. Very similar. And so if you plot that on for the India-Pakistan case, 50 teragrams, 150 teragrams. On global warming, you've got to really rescale it. If you put it on climate change of the last 1,000 years, this is the famous hockey stick diagram for the northern hemisphere, then temperatures, this is what you get. Now, before you ask, yes, this would solve global warming. But for how long? Well, I used the magic energy balance model to do this and put in soot. So I assumed CO2 emissions would stop, and so I published it as a modest proposal. There is an idea to put aerosols in the atmosphere and reduce global warming. It's called geoengineering or climate intervention. I'm going to give a talk about that next month at CU, which is probably also not such a great idea, but it wouldn't kill millions of people. So what's new here? A nuclear war between any nuclear states using much less than 1% of the current arsenal can produce climate change unprecedented in human history. Such a small nuclear war would have a huge impact on food. Nuclear winter theory was correct. The current arsenal can still produce nuclear winter, and the effects would last for more than a decade. So, do you believe me? Everything I've told you so far is theory. It's model simulations. Of course, Wackham's the best climate model in the world. We all know that. So maybe, the only way we can test these is with analogs. So the seasonal cycle. We all know it gets cold in the winter because there's less sunlight. Days are shorter, the sun's at a lower angle, so we have a feel for how much temperature can cool. Even at night, it gets cold. Unfortunately, we have examples of cities burning. The US burned 69 cities in the summer 1945 during World War II, starting with Tokyo in March, ending with Hiroshima and Nagasaki. So, and many of those produced firestorms. What about the smoke and dust transport? So we can look at examples from dust storms on Mars, from the asteroid impact that killed the dinosaurs, from forest fires, from Saharan dust, from volcanic eruptions. I'll just show you a couple of these. The asteroid impact produced fires and smoke and aerosols. Chuck and Brian Toon are experts on that. They give talks about that. There was a forest fire in Yellowstone National Park. I took this picture in 2007, but the fire had been 20 years earlier. And I did a study where I looked at the smoke. So this is a map of the middle of the United States. Here's Texas. There's the smoke coming out from Yellowstone on September 7th, 1988, September 8th. And I calculated how much the temperature cooled under the smoke by comparing observations to the Moss forecast, which didn't include smoke, and temperatures 5 or 6 degrees colder than normal. So smoke, even this light-colored smoke, can cause cooling. And then there's occasionally such strong forest fires that they pump smoke up into the lower stratosphere, and they're called pyrocumulonimbus. And so Michael Fromm is an expert on that, and this is from one in Canada. Well, a year and a half ago, there were huge firestorms in British Columbia, and so this is August 12th, 2017. And these are observations from OMPS satellite, which is a limb scanner. And this is the tropopause, and this is the equator, 50 degrees north. And this is the optical depth looking sideways, and this goes up to August 20th now, a week after the fires, and the smoke gets pumped up into the lower stratosphere. And you could actually see the smoke going up and being lofted, and over several weeks it gets lofted up into the several kilometers. So this is observational verification of what we found in our models, the first time we've ever seen this. And we wrote a paper, Pengfei Yu was the first author who used a version of Wacom and was able to model this, and it's in review in Science now. My favorite painting, The Scream. This is by Edward Munch. He said the sky was screaming blood and fire, and the person there has their hands over their ears to not hear the scream. The person is not screaming. And I think this was a volcanic sunset from the Krakatoa eruption that he saw over Oslo Harbor, and he painted it. Of course, you don't know if that's what he really saw because he was an artist, but so it reminds me to talk about volcanoes. This is the El Chichon volcano before the 1982 eruptions, and you can see the old crater and a little lava dome, and then afterwards it looked like that. This is the biggest eruption to that time in my lifetime in 1982. And I took satellite images with Mike Madsen and looked at where the aerosols went, and this was each of these maps is one day after the eruption, and within a week it went part of the way across the Pacific Ocean. Within 2 weeks it went to India. Within 3 weeks it went around the world. So this tells you something about transport of aerosols in the atmosphere. Although these were dust and sulfate aerosols, they weren't being heated nearly as much, and so they didn't behave as the smoke would. But the biggest eruption in the last 500 years was Tambora in 1815. This is the one that Ronald Reagan mentioned that produced The Year Without a Summer in 1816. And, what? Yeah. And yeah, he was there. The famous author Percy Bysshe Shelley, his wife Mary Shelley, was 19 years old, and their friend Lord Byron were having a vacation on the shores of Lake Geneva. I took this there. The Jet d'eau wasn't there, but they were in this house, and it was cold and gloomy and rainy, and they couldn't go hiking and boating, so they had a contest to see who could write the scariest ghost story, and Mary Shelley wrote Frankenstein, inspired by the climatic effects outside. And the book says the monster was climbing over the ice at the beginning, climbing over the ice at the end. And Byron didn't write a book, but he wrote this poem called Darkness, which I learned about from Russian scientists with whom we were collaborating in the 1980s when we were studying nuclear winter. And they saw the translation by Turgenev. So it's called Darkness. I had a dream, which is not all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless. And the icy earth swung blind and blackening in the moonless air. And morn came and went, and came and brought no day, and men forgot the passions of this their desolation, and all hearts were chilled into a selfish prayer for light. Wasn't really that bad. It was about a degree colder, but this is poetic license. It sounds just like nuclear winter. So how do you feel? This is also a picture I took before they told me to put my camera away. So Jeff Keel talks about this too. I'm sorry, it's really been a bummer. It made you think about something horrible. And the normal human emotion is to try and forget about it. As Mark Twain said, denial ain't just a river in Egypt. So you can go out of here and trust me and a few other people to solve the problem for you. That would maybe feel better. My reaction has been to try and do something about it, like Sherry Rowland said. So I'll just talk briefly about what I've been trying to do about it. President Obama and Medvedev signed the New START agreement in 2010. That promised that the US and Russia would lower their arsenals to about 2,000 warheads on each side. The number was actually 1,550, but they counted each bomber, each airplane as one, because they don't know how many bombs are in it. So maybe they each have 2,000. And this is about to expire, and so now the question is whether negotiations being going on to maintain the New START or even reduce it. The policy implications are, if the US and Russia immediately got down to a couple hundred weapons like all the other countries in the world, we couldn't have nuclear winter. We have terrible climate change, but it wouldn't be temperatures below freezing. It wouldn't produce famine for the whole planet. But if they want to stop any climate disturbance, we have to get rid of all the nuclear weapons. We have to abolish nuclear weapons. So I've been trying to tell the powers that be as much as I can about this so that maybe they can listen. In 1982, Alfonso Garcia got the Nobel Peace Prize for producing a treaty which got rid of all nuclear weapons in Latin America. So this is a map of the world. All the blue countries have no nuclear weapons. So there's no nuclear weapons in the southern hemisphere. The red ones are countries with nuclear weapons. So there's 1 in North America, 2 in Europe, and 6 in Asia. So Asia's the most dangerous place for nuclear weapons. The yellow and orange ones are ones that have treaties with those nuclear countries and sort of seem to think that maybe they'll protect them if they have, if a nuclear war comes. Includes Japan. It's a couple red pixels right here. I can see it. Brian and I wrote a paper called Self-Assured Destruction. Most people think it's mutual assured destruction, that if one country attacks another, the other will attack back and everybody will die. But based on our results, we said if one country attacks the other one in a first strike and the other one doesn't do anything, all the smoke from those fires would come back and cause global climate to change so much that everybody in the first country would die from starvation. So if you say, I'm using my nuclear arsenals, I'm keeping all these thousands of weapons to serve as a deterrent, you're acting like a suicide bomber. It makes no sense at all. They have to believe that you're crazy for deterrence to work. I was a lead author of the last IPCC report, AR5, and a chapter 8 on radiative forcing, and I put a paragraph in there about nuclear winter. And at first there I got a lot of pushback from some of the reviewers, even from Tom Stocker, who was ahead of it. He said, he had told us, look at the high-profile journals, Science, Nature, PNAS. I said, there's been a paper on this topic in every one of those. It was only one paper. It was by people I knew, but still. And so we put this in a box. Well, I said, the scoping document said we should look at fires. Well, we meant forest fires. It doesn't say forest fires, it says fires. So anyway, it's the first time. I decided, okay, social media. I know I'm old, but social media. So I started writing a blog on Huffington Post. I gave a TED Talk in 2013, 6 years ago. So far I've had 25,000 views, not very many. But a year ago, Brian Toon gave a TED Talk here in Denver, and he's had 2.3 million views. So the timing, I think, was everything. It's a really good talk, but it was at the time when Kim and Trump were threatening each other. My button's bigger than yours and stuff, and so people paid a lot of attention. So I decided I'm going to do Twitter. So I only tweet about nuclear issues, not about what I had for breakfast. And I've got 1,700 followers now, when Trump got elected, I said, what am I going to do? So I wrote him a letter, open letter, and I said, look, this is the nuclear arsenal that you're inheriting. The land-based missiles in the US are on a hair trigger alert. They're the most dangerous part. If you just take them off hair trigger alert, promised and dismantle them, the world will be much safer. That would be the first step. And if you do that, you'll get a Nobel Peace Prize. And it's gold, and it's shiny. Wouldn't you like something like that? But it hasn't worked yet. Maybe it's just because he doesn't read. But anyway, that's... I did. I tweeted it out too. I tweeted it too. That's right. The rest of the world is paying attention, though. So there were 3 conferences on the humanitarian impacts of nuclear war. First one was in Oslo I went to. The second one was in Mexico I went to. That's what I look like, the suit on. The third one was in Vienna, Austria. Mike went to it. Mike Mills went to it. And we told them about our work. And the rest of the world, more than 100 countries came, and they said, we have to get rid of nuclear weapons. And so they went to the United Nations in the summer of 2017 and put through in the General Assembly a treaty to prohibit nuclear weapons. It was amazing. All the diplomats who were sitting there in their suits, they didn't do anything, but the non-governmental group, the International Campaign to Abolish Nuclear Weapons, went there and did it. And so I'm banning nuclear weapons this week, beat that. And so the treaty was signed on July 7th, and it was written about, and the only article I saw was in the New York Times, a treaty has reached a ban, now comes the hard part, because the countries with nuclear weapons didn't sign it. So, wish you were here. So these are the 5 permanent members of the Security Council, just by chance are the first 5 countries to have nuclear weapons. The closest we've come to nuclear war is in the Cuban Missile Crisis, 1962. I took this picture near the Cuban Weather Service across from Havana. This exhibit is a replica donated by the Soviet government during the early years of the Cuban Revolution. There were 36 of these weapons, each one had a megaton weapon, so 77 times the destructive power of Hiroshima. It turns out there were tactical nuclear weapons there too that nobody knew about. Fortunately, it didn't start a nuclear war. Then I had the very surreal experience of being invited to Cuba to give a talk about this. And Fidel Castro came to my talk.
Can I walk out now?
You can walk, Rolando can walk out now, yeah. And afterwards, they took a picture and he signed it and gave it to me, and he gave me his autobiography so I could practice my Spanish, and then on his regular blog, he said, while the US and Russia each committed to reducing their arsenals down to some 2,000 weapons, the only way to prevent global climate catastrophe is by eliminating nuclear weapons. And Cuba has signed and ratified the treaty to prohibit nuclear weapons.
It's easy for them.
It's easy, they don't have them. Yeah, it's easy for them. They don't have them. They gave me a private tour of Havana, and they said, can we televise your talk? So they recorded it the next day at prime time. It was shown throughout the country. And we walked into this bar at the hotel, and they had a Julia Roberts movie on. I said, can you change the channel? And there I was giving my talk. And so I said,
Change it back.
no, exactly, change it back. I said, the only way people are going to pay attention is not a professor giving a lecture. It's going to be a feature film with this beautiful scientist in St. Petersburg collaborating with this handsome scientist in Oak Ridge, and meanwhile they're along the Kashmiri border, and you can imagine. But so far the movie hasn't been made, but I keep talking to people to get that movie made. Brian and I were able to publish an op-ed in the New York Times after Naomi Oreskes gave us the name of the editor there, and it was published, 3 years ago now. And two guys read it, R.P. Eddy and Richard Clark, and they wrote this book called Warnings about Cassandras, who are people that warn people about things and nobody pays attention. So Jim Hansen was chapter 12, warning about global warming, and I was chapter 13. And they gave me a Cassandra Award for being the best Cassandra, which I don't know if that's a good thing. And I gave demands a global audience. There were 52 nominees, and then I gave a talk in this fancy club in New York City to all these big muckamucks and former defense secretaries and senators and stuff. But so I'm just going to end with a quote from Carl Sagan. They asked him, "Don't you feel safer with nuclear weapons? How can we get rid of them?" He said, "For myself, I would far rather have a world in which the climatic catastrophe cannot happen, independent of the vicissitudes of leaders, institutions, and machines. It seems to me to be elementary planetary hygiene, as well as elementary patriotism." You can see why he was famed for being such a good communicator. So I think elementary planetary hygiene demands that we get rid of our nuclear weapons. The Nobel Peace Prize in 2017 was given to ICANN for its work to draw attention to the catastrophic humanitarian consequences of any use of nuclear weapons, and for its groundbreaking efforts to achieve a treaty-based prohibition of such weapons. Beatrice Finn, the director, when she received the Nobel Peace Prize in Oslo, said if only a small fraction of today's nuclear weapons were used, soot and smoke from the firestorms would loft into the atmosphere, cooling, darkening, and drying the Earth's surface for more than a decade. It would obliterate food crops, putting billions at risk of starvation. Yet we continue to live in denial of this existential threat. The story of nuclear weapons will have an ending. And it's up to us what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destruction is only one impulsive tantrum away. So I hope we can learn from that to keep our planet looking as nice as this for forever. Thanks. And if you want more information here.
Thank you, Ellen. It was an impressive talk.
Thank me for depressing all of you.
Let's ask some depressing, impressive, and yeah, let's ask some.
So you highlight the secondary effect of a nuclear war, which is nuclear winter. But even if that didn't happen, the fact that it's killing so many people, that's the primary effect. And you have downplayed it a little bit by highlighting a secondary effect. In reality, even if it didn't create a nuclear winter, it would be a major catastrophe for the world.
Absolutely. The direct effects would be horrible. They would kill, I mean, a nuclear weapon is not precise. It would kill everybody around, including many, many innocent people. And so those effects are so horrible that people have not used nuclear weapons again in more than 70 years. And so I think we've been really lucky that it hasn't happened, because rational people, of course, would not use the weapons, but you can think of irrational people in charge, you can think of accidents, you can think of hacking, you can think of, there was a case where a Norwegian sounding rocket was launched and the Russians thought the Americans were attacking them, and or there was a reflection in the ocean and they thought there were 5 weapons, and it hasn't happened. So the only way to, as Beatrice Finn said, they will be used if they can at some point, and so we have to get rid of them. But the direct effects have been so horrible that they've sort of shocked people into never using them again.
So, second question, you mentioned twice Alexandrov.
Yes.
Alexandrov has disappeared.
That's
Do we
right.
know what happened to him?
Vladimir Alexandrov went to attend, so I saw him in January in Los Angeles. He came to an AMS meeting, and then he went back to Moscow. He visited Jerry Potter at Livermore. A month later, apparently there was an attempt to dial into the Livermore computer from Moscow, to dial in. They suspected him, and they said, okay, he's never going to be able to come back to the US anymore, he must be a spy. In April, he went to a conference of nuclear weapons-free cities in Cordoba in Spain. He came back to Madrid and disappeared. They found his passport, airplane ticket on the street.
Russians or Americans?
So there are various theories. Andy Revkin wrote a big article about it, and there are various theories about what happened to him. Was he killed by Americans? Was he killed by Russians? Was he killed by somebody who was jealous of his access to? I mean, he spent 6 months here in Boulder, and he visited Michael Schlesinger, or Michael. He visited Michael. He also visited Michael Schlesinger in Oregon and traveled across the country. He and his wife came to my house in Maryland, and so he was he. Did they take him to? He had more experience on a Cray computer than any other Russian. Did they take him to Siberia to build the Kreisky? There's all these. Did he leave his wife and go to Italy? He spoke Italian. I mean, there's all these theories, but he disappeared and nobody knows. Gerastenchikov says that he has grandkids now. If he was alive, he would go visit them. So nobody knows what happened to him, and it was pretty scary at the time. I got a call. Have you seen from Mike Wallace? Have you seen Alexandrov? His wife just called me. He didn't come back to Moscow. Do you know where he is? Oh, let's not tell anybody. But apparently, then the CIA visited me to ask me about him. So they apparently didn't know, but nobody knows. So it's now Ruth Reck, who's did some climate science in the past, told me that she went to a cocktail party in D.C. A number of years ago, and there were some retired CIA and retired KGB agents there. And one of the retired KGB agents said, I know, one of my friends said he knows the guy that killed him, that was done by the Russians. So, because they thought he was a spy for the Americans too. That's all the information I have. I don't know. But he's probably not alive, but he was a nice guy, so it's really too bad. And it made me think a little bit, is it dangerous for me to work on this topic, because that's what he was known for. But Stenchikov came to work with me at the University of Maryland on volcanoes, and then to Rutgers, and then I got a job as a professor at the King Abdullah University of Science and Technology. So he's a good friend of mine. He's still alive and doing science. So it wasn't, I don't know.
So you mentioned the firestorms in the Second World War, and I was wondering what were the climate impacts of those?
What were the
climate
climatic
impacts?
I wrote a paper on that, which is published in JGR last year. You can get it from my homepage. What we did is we said there were 69 cities that burned. The U.S. wanted to bomb Japan, and they said if we bomb during the day the factories and things, they can shoot our planes down. And our guide, we can't really bomb that precisely anyway. So they decided to use incendiary bombs and bomb at night and just burn everything. And they sort of Curtis LeMay was in charge of this. He was the U.S. Air Force general. He said, I bet we better win this war, or I'm going to be tried for war crimes. But they sort of decided that every human being in every city was part of the Japanese army, because they probably all had a drill press or something in their backyard. So they decided just to kill people. They painted with napalm an X on Tokyo on March 10th, 1945, and then more than 300 planes came and dropped incendiary bombs and burned the city down. More people burned to death that night than any other time before or since in the history of the world. And every 3 days or so, they bombed 3 or 4 cities and burned them down. So the last 2 were Hiroshima and Nagasaki. So the policy of burning cities with innocent people in it was well established. It wasn't something new. It's just the atomic bomb was much more efficient. You only needed 1 bomb to do it. And the war ended not because of that atomic bombing, but because the Japanese military had basically crumbled. So we wanted to calculate. People have asked me that question: how much climate change did you get from that? So we had to do a very rough estimate of how much the temperature changed and or how much smoke there was from these cities. So we did a calculation of that. And then we looked at the data. How did the temperature change? Now, you may not know, but in World War II, the ocean sea surface temperatures are really bad because ships were in different places and they were switching from bucket to intake temperatures. And so there's a spike of temperatures in World War II with which over the ocean. And so we decided just to use land-based temperatures. We also found there's 2 observatories that measure the amount of sunlight, one at Table Mountain in California, one in Chile, and they tried to get rid of, only use clear sky, and we actually saw a little bit of a dip in the amount of incoming sunlight, and a little bit of a dip in the temperature, a couple tenths of a degree. But then we looked at climate model simulations of the control runs without smoke from these fires, and the natural variability was so large that these dips that we found were not significant statistically. So theory tells us it caused a couple tenths of a degree cooling, and that's what we observed, but it wasn't statistically significant. I've got lots of figures if you want me to spend 10 minutes showing, but the basic idea is that I was hoping maybe we saw something significant, but we didn't. But we got what we expect.
All right. Last question by Mike.
I guess there's a question here at the end, but also wanted to respond to Guy in that when you do this research, you get that sort of question of, there's going to be millions of people killed, and yet you're focused on the atmosphere part. And of course, in the 1980s, we knew that millions of people would be killed in a global nuclear war, and yet, as Alan pointed out, Reagan and Gorbachev cited nuclear winter theory as a reason for disarming. Another motivation for doing a study of India and Pakistan is this question of course, millions of people, again, will be killed, but we, on the other side of the world, will be very much impacted by this. And Alan, I know you and Brian have talked with people involved in defense strategies, and I wonder if this research has had an implication for their thinking about that.
Before I answer that, I just want to add to what you just said. This treaty to prohibit nuclear weapons was pushed by more than 100 countries in the world that don't have nuclear weapons, that realized they would be subject to terrible things, not the direct effects, but the indirect effects. And that was part of the pressure in the 1980s, but also now to get rid of nuclear weapons. So the rest of the world is trying to get rid of them because of these effects. So I told you I wrote a letter to Trump, but when Obama was president, we had a special session at the AAAS meeting in Washington to honor Steve Schneider when he died, and John Holdren was there, who gave a talk, who was the president's science advisor, and we went up to him, can you talk to Obama about this? He says, oh, I'm on your side, I'm part of Pugwash, but we don't have any evidence that he ever talked to Obama. Obama never said anything about it. At an AGU meeting 3 or 4 years ago, Rose Gottmaler, who was Obama's nuclear advisor, now she's like second in charge of NATO, I went up she was giving a talk in a session about detection of underground tests. That's why it was at AGU. And I said, you know, President Obama could reduce our arsenal without a treaty. You don't need a treaty to reduce it. The treaty tells the maximum, not the minimum. Oh, no, no, we can't do that. We can't do that. I said, but there's a precedent. President George H.W. Bush, when the Soviet Union was falling apart, drastically reduced the American arsenal without a treaty, and the Russians followed. Why would Iran or North Korea listen to us when we tell them they shouldn't have nuclear weapons? It's like, well, why do you have them? Oh, we need them, but you don't. Well, what's special? Why is the U.S. any different than any other country? It's like you're sitting in a bar telling people not to drink. If Obama reduced our arsenal, started to get rid of it, that would demonstrate to the world that we don't want them, we don't need them, and he's promised to do it, and he didn't do it. So that's what we've tried to do. We've tried to get publicity. We've tried to talk to them, and as far as we know, Ralph Cicerone was at this thing at AAAS, and he was the president of the National Academy of Sciences, and he's a well-known atmospheric chemist. And so Brian and I knew him. We walked up to Ralph, can we have a National Academy report on this? Because in the 1980s, there was a National Academy report on this, and it was very influential because it said the science was right, and they've been doing, and now they're not doing them. And he said, okay, sounds like a good idea. And then several months later, we had a telecon with him and his people, but then it never happened. So we tried to get the National, we tried to get, part of the National Academy thing is money, so if Congress passes a bill or orders them to do a report, they will. We tried to talk to congressmen to do it, so we've been trying, but we're amateurs at politics. We're scientists. We don't know how to do this. We do the best we can. So if anybody has any ideas of how to get more publicity about this, I thought the Nobel Peace Prize for ICANN would be a real stimulus. And now the treaty needs 50 countries to ratify it for it to come into force. So far, 23 countries have signed it and ratified it. Brazil, I was just in Brazil a couple weeks ago. Brazil has signed it but not ratified it. So I was in Sweden this spring at the invitation of Pugwash, and in Sweden, they're not part of NATO, and they're a pretty peaceful country, although they didn't used to be. They say they're afraid to sign this treaty because they think that they depend on NATO if the Russians attack, and they don't want to get NATO angry at them. So it's complicated, but if you really understand what would happen if they're ever used, it seems to me the only logical thing to do.
Okay, I think we are running over time already, so let's thank Ellen one more time. And